Hello, my name is Ebenezer Sarfo Adu. I'm a business strategist, a data specialist, and as well as a business consultant. I consult for many organizations on data and business strategy. Today, we'll be looking at data science methodologies. Thank you for joining us. My earlier videos were about what data science is, as well as how to become a data scientist. The objective of this channel is to help people who have no idea of data science. They would want to have careers in data science, but do not know how to go about their journeys. So I'll break data science down and make complex methodologies or complex concepts quite simple. After all, that's what data science is about solving problems, making complex problems look very simple. So today, I have for you data science methodologies. You may have a data project, a project that you may want to solve one problem or the other. The question is, how do you go about it? These methodologies are to aid you. These are standard methodologies on the market. I was not the one that developed it, but they are very useful and it helps any beginner or even an advanced data scientist to also go through projects without any hitches. So I'll be taking you to three main methodologies. There are several of them out there, but I'll be taking you to three main ones. But I'll spend more time on the one that is my personal favorite, which is the CRISP DM. So there are three of them. One is KDD. KDD actually stands for Knowledge Discovery in Data. Some say Knowledge Discovery in Data Mining. Depending on what you want to choose, I'm not too much of a fan of terminologies. The key thing is getting the understanding. So KDD is one of the oldest methodologies in carrying out data science projects. Then there is SEMA, which is an acronym for Sample, Explore, Modify, Model, and Access. And that is also another methodology for gleaning insights in data. And my personal favorite, CRISP DM. You might wonder what is CRISP DM. It's actually an acronym also for Cross-Industry Standard Process for Data Mining. And I'll spend more time on CRISP DM. But for now, let's go to KDD and SEMA, just a brief overview of them. Okay, so KDD. KDD, as you see, the name stands for Knowledge Discovery and Data Mining. It has variants of the meaning. I prefer knowledge discovery and data. Yes, I mean simply that. So KDD process tells us that we should first begin with selection of our data. You need to determine what data you are going to use. You need to look through your databases and find out what actually is in the database and what you need to actually select to do your project. Then you go through a pre-processing phase. And in the pre-processing phase, it means that you need to actually find some key things that you would want to look in your data set. Maybe you want to do some small transformation. Maybe there are empty cells. You want to fill that up. You pre-process the data. Then you go into actual transformation, which is removing columns, maybe merging data, trying to make it easy for the analysis. Then you go through the data mining itself, which is you are seeking patterns before the interpretation and evaluation. Interpretation meaning that you may want to visualize the solution that you have created. It's quite simple and straightforward, but that's not my favorite. So let's continue. Then there is SEMA. SEMA is by the SAS Institute. It's an acronym, like I said earlier on, for Sample, Explore, Modify, Model, and Access. So sample, you get like a large data set, then you sample, then you explore, like visually look at it and see some descriptives of the data. It's quite similar to CRISP, but I'll not spend too much time here. Modify, you transform the data, then you model. You put up your models, your techniques, whether it's a support vector machine or whatever model you are trying to actually come up with to solve the problem. Like I said, the essence of everything you're doing is to solve the problem for a business. Then you assess. I mean, you have to evaluate your model to see whether how accurate it is or whether it's even useful for the solution you are claiming it has. But I will also not spend more time here. Let's go straight into a CRISP-DM. Like I said, CRISP-DM stands for Cross-Industry Standard Process for Data Mining. My personal favorite, and maybe you understand after we go through. So the CRISP-DM process encompasses the end-to-end, to me, of data science, and it explains a lot about what you need to do. So CRISP-DM starts with the business understanding. You need to understand the business or whichever organization that you are going to work for. I mean, where the data is coming from an actual source or because of an actual processes being carried out. So if you are going to model data on healthcare, the CRISP-DM standard says that you should understand the healthcare. You should understand the business that you are actually going to solve. I always tell IT people that you need to have business understanding. It's not good only to have the data. You need to understand the business. That is where you can glean actual results that will make meaning for the end user. Then you go to your data understanding. You need to understand the data that you are actually working with. You need to understand what the data is saying. Let's say if you are working for a healthcare organization, they said there's a column called um, infection rate. You should understand some basic things. We'll go through deeper for you to understand what I'm talking about. Then there's the data preparation, of course. We cannot model any data without preparing the data. Then we actual model to see our results, we evaluate, then we deploy. Then there are several iterations and that doesn't mean it's just straightforward. You start data. Sometimes you get to your data preparation stage, you have to go back and correct some things and come back. So you can see that clearly it's an iterative process. So let's go through it one after the other. Number one, business understanding. This is trying to understand the problem to be solved. And in here, that's where your creativity comes in. You need to get the business understanding. If it's a healthcare that you're solving a problem in, if it is finance, it's in economics, it's important that you take time to understand the business before you actually start the data modeling or anything that you do with the data. So understand the business, understand the problem that the client or the people want to be solved before you start any data science project. It's very important. So I'll take you through some main steps you do in the business understanding phase. Determine the business objective. What do they want from the data? What is the problem? Then assess the situation. What is happening here? And why do they even want to analyze or understand or model the data? Then determine the data mining goals. What am I going to do as a data scientist? Then you produce a project plan. So that's why I love it. It actually makes it look more of a project that you starting and there is an end to it. So you go through this particular phase. So these are the steps for business understanding. Point two, data understanding. You need to understand the limitations of the data, the strength of the data. Mind you, data is costly. Even gathering the data is costly. So you need to understand the data and know what data sets you might need. It's important that you need to look at the cost benefit analysis of the data collection. Sometimes some data you may collect and may not actually be useful. So you need to understand the data. You need to understand the columns, the rows, what is in the data itself, and what data that you can get out there to actually carry out your model. So it includes collecting the initial data, describing your data, finding some descriptives, and then exploring the data. You can carry out a cursory exploration with some some visuals. We'll actually go through this entire CRISP-DM process with an actual project. Then you verify the quality. It's important because data, they say, beats algorithm. Irrespective of how good your algorithm is and your data is not good, you are going to come out with the wrong results. You're as good as the data that you have. So verify the quality of the data. Get to the source, find out how it was collected before you start even your model, before you waste your time. So it's important you understand your data. Three, which is the most important. I would probably overemphasize this in most of our discussions. Data preparation is very key. You need to prepare the data. You're going to spend most of your time in data preparation as a data scientist. So make sure that you prepare the data very well. You're going to transform the data into most applications would require the data is transformed to a certain level so as the application or the technology can actually analyze or build models on. So you're going to understand this as we carry out most of our projects in my next and subsequent videos. So it's important that you prepare the data, and the steps includes selecting the data, cleaning the data. You have to clean the data, then construct the data. Maybe build relationships in the data, then integrate the data into your model. You'll be getting data from different sources, and you have to integrate the data. This is a quick move over the Christian. We might take it one after the other in my subsequent videos, but this is too important. So some of the examples of things that you may be carrying out, um, data preparation includes conversion of data types, maybe from text to number. You correct your date table. Then you fill empty data. I mean, there might be empty cells, some null cells, which would affect your data. You have to remove duplicates. Otherwise, you would be actually not be doing any justice to your model. Then you have to sometimes merge. So these are all transformation tools that then remove some unnecessary columns. So it's important that you spend more time preparing the data. You know how come I love Christian. You can see that it actually opens you up and takes you step after the step what you need to do to actually carry out a project. Let's go to step. So four is the actual modeling. The model is about understanding the patterns. Mostly data science about looking at patterns and using that to predict the future. Some of the steps that you'll be carrying out is selecting the modeling technique. What technique are you going to do? Support vector machines, random forest, decision trees. What kind of modeling you do? Or probably maybe a simple analytics that you are doing. Um, it may not be. I taught you about the three types of analytics. Check out my other video on the three types of analytics in my first video. You have to generate a test for the model. You have to actually test for the robustness of your model. Then you actually build the model. Like I said, we'll take your time and go through these phases with an actual project so you understand. Then you need to assess your model, whether it's accuracy or precision that you're going to use to judge. But it's important that after building a model, you need to assess it. And probably there might be some test set that you might have to use to train. And there's a training set that you may have used. So it's important that you assess whether your model is good and given the solution that is needed. Because that's the actual reason why you started, to provide solution. Then you have to the model. Check and see if the model answers the business problem. Because it's all about problem solving. It's not about building nice models. It's about solving the problem. If a simple dashboard of just product versus sales can solve the problem and make the client get insight into what the problem is, that's fair deal. Don't be too much of just trying to show how good you can use different techniques. The key thing is about problem solving. So you need to evaluate your results. At best, go and check with the actuals on the ground. You can have a test data by the side so as you can test that with the actual results on the ground so as you know whether it is what is there. For instance, maybe you are running analysis on bank balances. You can intentionally let them hide some bank balances and give you some um, training set that when you are done, you check and see whether it's the same as the actual that they have. It's very important. You review the entire process that you went through. And this is also an iterative process. You could go back to the data preparation or even go back to the business understanding to see whether you really understood the business. You need to determine the next steps after evaluating the model. And the last is the deployment. So you have to deploy to wherever you are going to. That's where it's going to be used. The actual deployment requires that you plan which area is going to be used, who is going to use the model, and you need to plan it. And you have to plan the monitoring and maintenance, because there might be tweaks when new data come in. You might have to actually go and do remodeling to actually go through whether your model is still accurate, and produce a final report for your client, and they'll be happy, and you may receive some applause. So thank you. Review the projects, the last thing you do in deployment. Thank you very much for your time. Subscribe to my channel. The name is Ebenezer Sarfo Adu. Catch you in the next episode. We'll have to take our time and go through all these methodologies one after the other, especially the CRISP TM. So see you next time. It's bye for